Right. So greetings, YouTube, beautiful mind here. So we are continuing our discussion on chapter 1, differentiation, and this will serve as our lecture for section 1.6, the product and quotient rules. So I think with the last section, we kind of went through some of the essentially shortcuts for differentiation. Initially, when we introduced differentiation, the derivative is the slope of the tangent line at a point of a curve, right? And so we introduced kind of the derivative with the limit definition of the difference quotient. Initially, it was like the limit is h tends to 0 of the difference quotient. Then, so in the last section, we kind of started to review some of the shortcuts that we have for finding the derivative that bypasses the limit definition of the difference quotient. So this section is going to be more of those shortcuts, namely the product and quotient rules. So some objectives here, we like to differentiate using the product and quotient rules. And then we'd like to use the quotient rule to differentiate the average cost, revenue, and profit functions, okay? And the product rule, to let f of x be f of x times g of x, so we have the product of two functions, then f prime is going to be the derivative with respect to x of the product of those functions, so d by dx of f times g. And then, so the product rule basically goes the first times the derivative of the second plus the second times the derivative of the first. You see it here. The first times the derivative of the second plus the second times the derivative of the first. That's the product rule. No, the first time, 1d2 plus 2d1. That's one way you can look at it. Anyway. So for example, we're asked to differentiate this. This is the product rule, direct application of the product and the sum and quotient rule, right? So equal to, and I would like to confirm that this is streaming properly. All right. So now, if we're going to apply the product rule, the first times, okay, so we're just going to rewrite the first thing. So we have x to the 4 minus 2x cubed minus 7. So the first times the derivative, d by dx, of the second, which is 3x squared minus 5x. We're going to say plus the second online times the derivative of the onto one line. Ahead and differentiate. The first one just comes down. So we have x to the 4 minus 2x cubed minus 7. Derivative of that part, 3x squared becomes 6x. Right? 3x squared minus 5x times, that derivative is going to be 4x cubed minus 6x squared. Is 0, right? So then we can just expand these out and combine like terms. Are there any common factors? There are some there. I'm just gonna, it's kind of a lot, but I'm going to expand these all the way out and then just combine like terms. All right, so first I'm gonna do 6x sums everything. So we have 6x to the power of 5, 12x to the power of 4, minus 42x. Right? And I'm going to distribute the 5. Minus 5x to the power of 4 plus 10x to the power of 3 on this side. 4 times 3 is 12x to the power of what? 5. 20x to the power of 4. 10x to the power of 4 plus 30. 3. So then we want to combine like terms. Okay. So we have, let's the power of 5 and a power of 5, right? So if we close, well, 18x to the power of 5 plus, let's do this color. Here's a power of 4, here's a power of 4, here's a power of 4, right? So means negative 12 plus negative 5 is negative 17. Is a negative, what, 37? And 5, right? X to the 4, okay? Please, I'll use this color. Here's the power, okay? 3. E squares. Um, 42x, and then I think the last one will do like this, 35, and that's it. Expand it all the way out. Let's try this and see what happens. Forty, 42, and 35. Oh, do we? Expand it all the way out. Oh, so they stopped here. Okay, well, so I'm just going to confirm that we have that line. I think we have that line. So we just did a little bit extra here. They stopped here. I'm just going to keep what I had. And I felt like I was probably doing a little bit too much. It just depends on how they want the answer. Because sometimes you do expand it, sometimes you don't. I'm going to leave these as exercises, these quick checks. I'm just going to leave those for you and keep going. In here, if you would like to practice. So then now, so we saw an example of the product rule. So then we want to take a look at the quotient rule, right? So say we consider like one polynomial divided by a second, then the derivative of that quotient basically goes low d high minus high d low, right? So low d high minus high d low over low squared over low low, right? Again, it's low d high minus high d low all over low low, right? So what I'm saying is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, right? To find f prime of x in this case, we go low d high minus high d low over low low. So low is x minus 1. D high, which is a derivative of the top, that's going to be 2x minus 3. That's low d high minus high, which is this guy, x squared minus 3x. D low, the derivative of the bottom looks like it's just 1 over low low, which is going to be x minus 1 squared. Factors, we could factor out of x. We'll have x minus 3. 1. I don't think there are any common factors, so I'm actually just going to stop here. And treating it in a similar fashion like we did the previous example. So, well, yeah, it's not a big deal. So if we expand it, then we'll get, let me see, the first, so if we FOIL that first one, that's going to be what? 2x squared minus 3x minus 2x plus 3 minus x squared plus 3x over x minus 1 squared, right? Terms, that's x squared. I think these two cancel each other out. So this is canceled by this. 2x. X plus 3. That, no, that's it. Okay. Maybe we could factor. Does it factor two numbers that multiply? Is it 1 and 3? No, because it would have to be minus 3 and minus 1. It's that 2 that's throwing things off. It was almost factorable. Okay. Next now. As an exercise, here's the solution. If you need me to work through this, if you have questions about any of these quick checks, just let me know and we can talk about them. See, we have some definitions. It says if C of X is the cost of producing X items, then the average cost of producing X items is given by this. If R of X is the revenue from the sale of X items, then the average revenue from selling X items is R of X by X. The profit from X items, then the average profit of selling X items is this. Right? Just give you the total, like this is the total cost, total revenue, total profit. So whenever you want to find the average, you take the total divided by the number of items. So if you have 10 items, you take the total cost divided by the 10. So this is like the total cost, total revenue, total profit, and the X are the number of items produced and or sold. So then if you want the average, it's the total divided by the number of units, right? So these make sense for average cost, average revenue, and average profit. House finds that the cost in dollars of growing X hundred geraniums is given by this function here, right? All of this. Sale of X hundred geraniums is given by this. This is our revenue function. Here's our cost function. Find each of the following. The average cost. So average cost, okay, so X has to find the average cost, the average revenue, and the average profit when X hundred geraniums are grown and sold, and then the rate at which the average profit is changing. Sounds like the derivative, right? Derivative of these average. It says that the rate at which the average profit is changing when 30 geraniums are being grown. So that sounds like the derivative of our average profit function. Okay. I'm gonna need some space. I'm gonna get a copy of these functions. Here. Okay. Copy. That's why it's not copy and paste. There we go. Rid of the crop. Cost function. Function. Enter, but we got copies of our functions. We're asked to find the average cost, average revenue, and average profit. So let's go ahead and find our profit function. So a profit function, if you have a business, right, you have the money generated by your business and you have the cost of running a business. So then the profit is going to be the net or the difference of your revenue minus your cost, right? So we're going to say your revenue minus the cost, okay? That's going to be plus 90 times the square root of x minus, now we've got to be sure to distribute our negative. It's going to be minus 200 minus 100 times the fourth root of x. Any like terms, 120 minus 200. Nope, not 120. Hundred. Average cost is going to be C of x by x. So then that's going to be 200 plus 100 times the fourth root of x over x. I'm tempted to just leave it like this, to be honest. So then our average revenue is going to be R of x over x. 20 plus 90 times the square root of x all over x. But then our average profit, P of x, will be the square root of x minus 100 times the fourth root of x all over x. I'm gonna just leave it like this for now, okay? Let's do like this, paste. Access to the rate of change, the rate at which the average profit is changing with 300 geraniums. Taking the derivative of our average profit function and when x is 300. The profit function with that. So low. So we basically want to do d by dx of this p of x over x. Low, d high. Derivative of our profit function. Okay, I need some more space. Let me get rid of this. I'm going to do d by dx, the average profit, p over x. So low, d high, so derivative top. $80 is gone. Square root of x, let me see, that's going to be times 1/2 x to the negative 1/2. I'm gonna leave it like that for right now. It's gonna be minus, now that's a 1/4. The 1/4 comes down, so that becomes what, 25 x to the power of negative 3/4, right? Because you got to say 1/4 minus 1. I'm going to leave that like that. So the bottom times the derivative of the top minus the top x to the x. Let's see. For the top minus the top times, now the derivative of x is just 1, so we can leave that over the bottom squared. Now this may have been a little bit easier if we had like rewrote, just go ahead and distribute the x into the numerator. We'll try this. If we get it wrong, we're going to come back and rewrite that profit function. We want to simplify it now. But let's keep going. We're almost done. And what we can simplify. Up minus some to the parentheses here. Top minus the top times the root of the bottom. It's a little bit like jumbled, right? You know, we can like say that 90 times the half. We can distribute this x into there. But instead of move forward with this, what I'm going to do is I'm going to go back and try to work with something that's a little more simple. I'm going to leave that for now because we can always come back to it and kind of expand it out further. But I'm going to put a pin in that. And instead of using the quotient rule, I'm going to go ahead and distribute the x and simplify that down, and then just try to use the other rules instead. I feel like that'll be a little bit easier. So I'm just going to kind of put a squiggly here to kind of signify I'm just going to I'm going to go back. So here, let's do it like this. X. Let's simplify that down. Now, if we were to distribute the x into the top, that first term becomes negative 80 x to the negative 1, right? Now we got that x, like we got that square root of x. That's x to the power of a half. So a half minus a whole is a negative 1/2. So that's going to be plus 90 x to the negative 1/2. And then that fourth root of x is really x to the power of 1/4. So then if we say 1/4 minus 1, 100 x to the negative 3/4. Now, this should be much easier than trying to do the quotient rule, right? So then now when we do d by dx of this average profit, right, we're going to get, now we can just use like the power and sum and difference rules. The negative 1 comes down, so that becomes 80 x to the minus 2. That 1/2 comes down, that's going to be a minus 45 x to the minus 3/2. The 3 comes down, what is that, 75? So plus 75 x to the by 4. Okay, let's go with that for now. So we wanted to evaluate this when x was 300. Let's say at x equals 300. So then d by dx divided by 300, essentially. Basically, I'm just going to plug in the 300 for all the x's. So we're going to have 80 times 300 to the power of a -2 minus 45 times 300 to the power of a -3 by 2 plus 75 times 300 to the power of 7 by 4. Okay. I'm going to put this in my calculator and let's see what happens. I'm trying not to look at the answer. Trying to see if I can write something on my own, which is actually that was it. And keeps putting. No. Okay. So now I'm just going to type this in my calculator and let's see what happens. And then, but you see why I stopped? Because I mean, we could have kept going with the quotient one, but it was getting kind of nasty. So I was like, okay, let's just pause on that. Since I think we had the ability to go back and rewrite that average profit function. So I was like, let's simplify it and then try to work with the other one instead, right? So let's go ahead and crunch this and see what happens. So we get this 80 times, we got 300 to the power, let's do it like this, 300 to the power of a -2, okay? 45 times 300 to the power of a -3 by 2, okay? 75 is 7 by 4, okay. Cross our fingers, let me see, what are we anticipating, right? The rate at which the profit is changing when 300 uraniums are being grown. Increasing or decreasing, we could get a negative. So we got 0.0043. So the profit is decreasing by percent at that when that many are being. So it's almost like you're breaking even almost, but it's still in the red. So let me write this result and let's see how do we do. So now we got that this was approximately, I'm going to just write it here, negative 0.00, I'm going to say 4302, 430. So we got, let's see what's the prepared under. This to the prepare notes, right? We let, okay, so they abbreviated the average cost, right? Average cost, average revenue, and average profit. Average cost, C of X over X, we got that, and I don't think they simplified a lot, they stopped there. So we got these, those were okay. Right. Good. So the average profit was basically the revenue minus the cost over X. We got that, and I think we got this, right? So that looks good. So then first we got to find A prime. Now they did the quotient rule, right? Now this is where we stopped. I think we stopped about here, right? They went on expanded, so you do have to have like be meticulous. Like if this is to the power of 1 when you distribute, this is going to be a positive 1/2, a positive 1/4 because you add the exponents, distribute the negative, and they got there. Did we get those numbers? Let me see. 45, 25. I don't think we got those numbers. I feel like we're missing something. is 45, 75. No, we're missing something. We're gonna go back. Oh, maybe not. Let's see. Okay, continue. All right. Right here. They do have some like terms. Yeah, 75, right? We got the 75. And I think that's a negative. I think we got it, right? Because it's 45 minus 90 is a negative 45. Negative 25 and 100 is 75. So a negative 45 and a 75. Let me see. 5, 75, and 80. Those are the main parts that I was looking for. It looks like we're on the same page, right? So they use the quotient rule, which is nothing wrong with it. And we could have kept going what we did. I just didn't feel like trying to sift through all of that, right? So I was like, okay, let's just simplify it down and see if we can work with something that's easier. And I didn't erase what I had because I was like, well, it's not wrong. At least I don't think it is. I just didn't want to be meticulous and go back. I was being lazy, right? So I was like, okay, let's go back and simplify that average profit function, and then let's try to work with the simplified form instead something that was easier to crunch. And a lot of this was just about being neat and having plenty of space and being organized. Okay, so then they did 3, and we plugged in 300. There. Now right here. How about x squared? That's going to be x to the minus 2. Did we miss that one? Let's go back and see if we can find it. Got the x to the minus 2. We got 3 halves and a negative 7/4. So I'm trying to think, what are we missing? Here, f minus 2 is a negative 3 halves. Did I forget my 4? I bet I forgot my 4. I think it was when I put it in the calculator. I think I found it. So what I'm going to do is pull up the calculator real quick. I think we did a keystroke. 100 to the negative 2. 45 times 300 to the power of a negative 3 halves. 75 times 300. Is there a typo? They're being grown. I'm going to do one more time before I try something different. X to the minus 2, we got that one. Minus a quarter minus is negative 7/4. Yeah. Plus. Yeah, we got the same thing. I'm trying to figure out why our number looks so different. Thing I could think to do different, but what I'm going to do is change my 300s to 3s. There's a 300, 300. Yeah, I don't know why it looks so different. Because even this, even like what I have in the calculator is the same as what they have. It's just keeping track of it. Let's hit delete and delete. Hundreds of dreams. Yeah. That's so weird. Paulson's average profit is increasing by about $11.20 per plant. So then the only question I'm stuck at is like, why 3 instead of 300? Just the geraniums. Okay. Okay, I get it now. So because this function was built in terms, X is like in hundreds of geraniums. So how many hundreds do you have? You have 300s, right? So when I put 300 in there, that was saying 300 hundreds, right? That's why I was throwing things off. So I did need to make that adjustment where instead of putting 300, you definitely should have put 3 instead of 300. But yeah, so that's kind of how some of these go though. It's like, let me just go ahead and make those changes. So that was the only thing that we were doing wrong. We put in the 300 instead of 3, right? Because again, this model was based on X already being in terms of hundreds. So we should have just did the 3, right? Okay, that wasn't too, I mean, that was intense. I can get it. I can see it, but you know, it is what it is. And we got the right thing. 11, we got 1120. So we can get rid of this. So yeah. Well, we got it. Like again, the main thing was what you see in red. We just put we were just doing 300, or we should have just did 3, and that's what we was doing. Yeah, because I kept checking. I was like, no, the numbers, everything is matching up. So where are we going wrong? Okay. Well, that was an adventure, but we got to the bottom of it. But that's how these things go. Like you do your best, you check, and then you know you kind of go back. You kind of keep going back and forth until you can get to the bottom of where the mistake is, right? But we found it. Okay, and then as a quick summary, it says the product rule again is basically first times the derivative of the second plus the second times the derivative of the first, right? And then the quotient rule, the way I remember that one is low D high minus high D low over low low, which is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, right? So then be careful to note the order in which you write out the factors using the quotient rule, because the quotient rule involves subtraction and division. The order in which you perform the operation is important, right? So the order is very important when you're doing the quotient rule. Okay. So that was an adventure, and again, I do it. I intentionally I try not to look at these in advance, and I try to do them on the fly because I want you to get a sense of how to think, and you know, it's not always just like so clear and straightforward, right? You have those moments where it's like, okay, wait, I made a mistake. Like, okay, you need to. It's important to be able to identify, okay, something doesn't feel right. Did I make a mistake? Let me go back and check. And like, so what you see me experiencing is like what I expect you to do. Like, if you make a mistake, you got to take a breath, pause, and try to get to the bottom. Where did I make the mistake? Why is that wrong? What's wrong with my logic? Like, I do that intentionally. I could obviously, you know, do them in advance and prep and then go back and edit and cut and redo and have a clean run. But I'm trying to be more realistic. These experiences are not always perfect, right? They're not always clean. So the to me, the mark is being able to adjust in the flow and catch the changes and the mistakes and recover from them, you know, a lot like in life, right? So again, that's why I try not to look at these in advance, and I try to do it fresh so you can see how the experience can go, right? But anyway, it is what it is. We found that we got to the bottom of it. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, take care, guys. Peace. Yeah, I don't know what she's doing. She's like losing her mind. I think she has cabin fever. I probably need to like take her to a park or something. Your weekend or the rest of your day.